Okay, Assalamualaikum and a very good day to all students that are taking this course. So for today, we are going to go to chapter 3. Uh, Chapter 4, which is Material Engineering Technology. For this course is BNQ 30503. So the chapter 4 regarding the application and processing of metal alloy is very important because the application and processing of metal alloy are integral in so many industries ranging from construction, automotive to aerospace and also electronic. So here we will delve into the various type of metal alloy, their application and their typical processing method used for the manufacture and shaping of this type of materials. The content review. For chapter 4, what you will learn for in chapter 4 is for this chapter you will learn the ferrous and also regarding the ferrous alloy, the non-ferrous alloy, thermal processing of metal, annealing process, heat treatment of steel, precipitating hardening. So this will be covered in part 1 of this lecture. So part 2, you will delve into the phase transformation, the rate of transformation, the transformation and undercooling and mechanical properties of the processing of this type of materials. Classification of metal alloy. Okay, as you know, metal alloy it can be classified into ferrous and also non-ferrous. So, and non-ferrous, okay, just you know, it can be divided into for the non-ferrous and ferrous type of metal. Okay, for the ferrous metal, it can be subdivided into steel and also cast iron. Okay, for the cast iron is the microstructure or it consists of microstructures of ferrite, graphite, and cementite. For steel, it consists below than 1% over the carbon content. So in the graph here, you can show the adaptation of from the materials of that consist inside of steel and cast iron and how they are placed categorized according to their content of structure. Okay, so this diagram exhibit for you a better understanding regarding the type of metal alloy, which is ferrous and non-ferrous. For the ferrous, it can be classified into steel alloy, or it also can be classified into cast iron. For the type of steel, it can be further classified into low alloy. So low alloy can be subdivided into three classes, yaitu low carbon, medium carbon, high carbon, and whereas for the steel, it is further subdivided into high alloy. For the cast iron, it is fall under category of ferrous. It can be classified into 5 different groups, which is gray iron, ductile iron, white iron, malleable iron, and also compacted graphite ion. For the low alloy, it can be subdivided into three classes, and then these three classes consist of it constituted by the amount of carbon, whether the alloy consists of high carbon, medium carbon, or low carbon. So it can be further divided into plain, high strength, low alloy, plain, heat untraceable, plain, and also tool stainless steel. Okay, as you know, the steel alloy is also consists of the carbon alloy here, carbon alloy, or it's also considered as carbon steel. So carbon steel widely used in type of construction, such as automotive, manufacturing, and industry, due to its strength and also versatility. Whereas for the stainless steel here, it can be also used for its corrosion because of what? Because it's corrosion resistant. So it's used in medical instrument, kitchenware, and also construction. So this is where stainless steel is being used widely. Okay. For the tool steel, okay, it is used for making cutting and drilling equipment due to its hardness and resistant to wear. For the aluminum type of iron, uranium or also aluminum lithium alloy, it can also be used as what? It can be used as in aerospace application due to its high application to its lightweight and also high strength. Okay, so as you know, okay, copper alloy is also type of alloy. It is being used as what? This is being used as a bearing, bushing, and also music instrument due to its wear resistant and also acoustic ratio. Okay, still here. So you can see here how the steel is being subdivided into category of low alloy and also high alloy. Okay, based on previous slide, you can see the steel is being categorized into low alloy and high alloy based on what? Based on the carbon content. So low alloy being further categorized into low carbon, medium carbon, or high carbon based on the composition of the carbon inside this type of material. So if the material consists of below than 0.25% of carbon, it be categorized into low carbon. Okay, so low carbon. So the name is not next addition. So it is this is the property of this type of carbon inside this type of material. So these categories will give you the exact definition and or exact application of where this type of carbon is being used what the type of carbon steel is being used in what application. For example, low carbon is being used in automotive and also being used in construction. Okay, it can also be used in bridges, building towers, and also pressurized condition, and also in vessels. Okay, for high carbon, it is used that in condition that require very high resistance to weariness. Okay, and sometimes the high steel carbon is also being used as a cutting material, as a drill, saw, and also dies. Low carbon steel. So this slide explain to you regarding the low carbon steel. So in low carbon steel is considered as plain, in which is unresponsive to heat treatment, intended to form martensite. So the strengthening of this type of carbon is carbon steel is accomplished by the core work. So relatively soft and weak but with outstanding ductility and also toughness is the characteristic normally associated with low steel carbon. So it is also machinable, weldable, and least expensive to produce of all type of steel. Whereas for the high steel low alloy HSLA version contain alloys such as copper, vanadium, nickel, and also molybdenum in combined concentration as high as 10%. The characteristic of this type of high steel low alloy or HSLA is that it has a higher strength than plain low carbon steel, and it can also further be strengthened by heat treatment. So a characteristic what makes it different from the low steel carbon is that it's more ductile, formable, and also it can also machinable, meaning that it is easily manufactured into a different type of materials. So HSL sheets are more resistant to corrosion than plain low carbon steel in normal atmosphere. So this make why the usage of HSL steel is much required, also much demanded in real application compared to low carbon steel. Medium carbon steel. The medium carbon steel it can be heat treated by austenizing, quenching, and also tempering to improve the mechanical properties. Often utilized in tempered condition, having temperature martensite microstructure. Where furthermore, the plain medium carbon steel have low hardenabilities. It can only be successfully heat treated in thin section with very rapid quenching rate. The addition of chromium, nickel, and molybdenum help improve the capacity of the alloy to be heat treated. High carbon steel. High carbon steel. The hardest and strongest and least ductile of the carbon steel, almost always used in hardened and tempered condition, especially where resistant and capable of holding a sharp cutting edge. Tool and die steel usually contain chromium, vanadium, tungsten, and also molybdenum. The alloying element combine with carbon to form very hard and wear resistant carbide compound. Stainless steel. Stainless steel is known as a highly resistant to corrosion in terms of rusting in a variety of environments, especially at ambient atmosphere. Predominant alloying element is chromium, at least 11% by weight. It consists of chromium. Addition of nickel and molybdenum enhance the corrosion resistance, making it more resistant to corrosion in especially at ambient temperature. Stainless steel can be divided into three classes based on predominant phase in microstructure, martensitic, ferritic, and also austenitic. Addition of alloy change the phase diagram to enable austenite phase extended to room temperature for austenitic stainless steel. Austenitic and ferrite stainless steel are hardened and strengthened by cold work because they are not heat treatable. Austenitic stainless steel are the most corrosion resistant because of the high chromium content and also the nickel addition. Martensitic and ferritic stainless steels are magnetic. Austenitic steels are not. Strengthening is accomplished by precipitation, hardening, heat treatment. Refinement. This diagram shows you the refinement of steel from ore. You can see here how the set material is being inserted into the blast furnace, and in this type of processing, it is what it occur of heat generation producing the CO2, and the reduction of iron ore to metal occur via this type of reaction, and then it is further purified producing the products as a form of slag. So you can see here the material is being inserted from the upper top of this blast furnace. So if we will go to the refractory vessels, consists of layer of coke and also iron ore, and also there is air inside it to help further purify the specimen or the material, and then it will come out as a molten iron. Ferrous iron, ferrous alloy is an iron-based alloy. It consists of steel and also cast iron. Nomenclature for steel is according to AISI or SAE. Okay, then it consists of plain and also plain carbon steel. Uh, Furthermore, it consists on a plain carbon steel resulfurized for machinability, and the list goes on. For example, 1060 steel, if we consider as plain carbon steel, is 0.060 weights of carbon. The stainless steel has over than 11% of chromium inside of its composition. So the first, this is the indicator of how you give naming to this type of steel. The first two digits indicate the alloy content. So the first two digits here indicate the alloy content, whereas the last two digits, the X here, give the carbon concentration. Okay, you can refer to page 436 as in the reading materials. Okay, the cast iron. The cast iron consists of ferroalloy with over than 2.1% of carbon. More commonly, it consists of between 3 to 5 or 5% carbon. Okay, it has a low melting compared to steel. The melting is between in the range of 1150 to 1300 degrees Celsius. So is it meaning that it is relatively easy to cast. So basically, this type of cast iron is generally brittle. It is cementite, decomposes to ferrite and also graphite via graphification process. You can see here how it is being decomposed to ferrite and also graphite. So this process is relatively slow process. So the process occurs in the presence of silicon in its concentration greater than 1%. of weight of the materials. So the slow cooling rate during solidification is required to produce this type of materials. Okay, so basically you can see here, so this diagram show you the ferrum carbon through equilibrium diagram. So this you can see here, the graphite formation promoted via slow cooling process. So it's how the process occur according to the different degree of also different degree different concentration of carbon, and at what the temperature this process is required to produce this certain type of materials. So the type of cast iron. Cast iron, it can be classified into gray iron. Gray iron is, if you want to know, it look like a graphite flake. So basically, it's weak and brittle when it's being subjected to tension. However, under compression condition, it is quite stronger. It has excellent vibrational dampening, so it is more resistant to wear. At high fluidity or casting temperature, it can take a very good intricate shape. So the low shrinkage in casting gives it a better flexibility in during casting. So this is type of iron is considered one of the least expensive metallic metal. So gray iron is being used widely as a diesel engine casting, as a cylinder head, piston, and also other automotive parts. Okay, so ductile ion or non-dual ion, it has an addition of magnesium or other agri ion before casting. So the graphite is a non-dual or spherulite particle, not a fixed. So the matrix is spherulite or ferrite. So that is quite considered ductile. So the mechanical characteristic is like a steel, approaching the characteristic of a steel. So it is being used as a valve, pump bodies, crankshaft, gear, and etc. Type of cast iron. White iron. White iron it consists of below than 1% of silicon inside of it. It can be processed via rapid cooling rate. The pure light or cementite is made mostly of white iron with no graphite. It is very brittle and also hard. It is virtually unmachinable because of its characteristic of being very hard. It is used for roller in rolling mills, hard and wear resistant surface without high degree of ductility. So intermediary phase is in the production of malleable ion. So the malleable ion is heat treated white iron at 180 to 900 degrees Celsius, graphite in rosette and also cluster. Reasonably strong and ductile like non-dual ion. So malleable iron is used for connecting rod, transmission gear, and also pipe fitting, then etc. Compacted graphite iron. Okay, so it's also known as in acronym as a CGI. Silicon range between 1.7 to 3.0 overweight. The carbon range between 3.1 until 4.0 overweight. So graphite have a worm-like vermicular shape. Okay, this is intermediate between gray ion and also modular ion. The addition of magnesium or cerium in a lower molecular weight compared to non-dual iron. So the property change with graphite shape and the matrix or ferrite or pure light. Okay, it has a relatively high thermal conductivity good resistance to thermal shock. So lower oxidation at elevated temperature. So basically compacted graphite ion or CGI are used for diesel engine block, exhaust manifold and also gearbox housing. Production of cast iron. Okay, this diagram show you how the production of cast iron occur. So how the microstructure of the cast iron or look like according to the processing temperature. Whether it's being processed at high temperature, about 700 degrees Celsius for 30 hours. So and then it further processed into fast cooling or slow cooling. So it will take the shape of very tight malleable or periodic malleable. So, to check the shape of white cast iron and periodic gray cast iron or ferritic gray cast iron, you need to conduct the cooling at a fast cooling, moderate cooling, and slow cooling. Depend on the type of microstructure that require as your final product. Limitation of ferrous ion. Ferrous ion is relatively high in density. Furthermore, it is relatively consists of low electrical conductivities. Generally, is a poor corrosion resistant, meaning that it's more susceptible accepted to corrosion considered to other type of metal alloy. Okay, this is the comparative table show you the table that show you the differences between Cu alloy, Al alloy or Ti alloy, magnesium alloy or refractory metal and also noble metal. So from here you can see the comparative between each type of these materials. Copper and its alloys. So basically it's a soft and also ductile, difficult to machine. So however, it's also highly resistant to corrosion. However, this can be improved via alloying process. There are two main alloy categories, yaitu brass and also bronze. So basically, brass is alloy with zinc. It has up to 35% of zinc, and it also have a alpha phase that making it soft, ductile, and easily collable. Over 95% of zinc, the beta phase of BCC, making it harder, stronger, and hot will work normally. For the bronze is consists of alloy with this type of material inside of it. So it basically is stronger compared to brass and also it is good corrosion resistant. So it is being bronze is being utilized when good tensile properties with corrosion resistance are required. The beryllium copper. This is actually a alloy with beryllium content of 1.0 to 2.0 overweight. Okay, it is used with heat treatment, precipitation hardening process, high tensile strength, excellent corrosion, and also electrical properties. Okay, is requires where heat resistant when properly lubricated. Cast can be also be cast or hot work. It also can also be cold work. Aluminium and its alloy. Aluminum in its alloy has a low density between 2.7 gram per meter cube compared to 7.9 gram per meter cube for steel. Aluminum and its alloy also have a high electrical and thermal conductivity. It also has some corrosion resistance in some common environment. Okay, aluminum and its alloy has high ductility even at low temperature. Low melting point, meaning that it can be processed at temperature of around 660 degrees Celsius with a restricted melt temperature. It can increase strength by cold work and alloy, but will reduce resistance to corrosion. Alloying include this type of materials require in precipitation hardening is due to precipitation of two elements other than aluminium. So aluminium and alloy is classified as cast or rod. Okay, specific strength aluminium have lower tensile strength, but on weight basis it can support more load. So it being used in a transportation because it only require small minimum fuel consumption. Okay. New derivation of aluminum and alloy is an example of this type of new aluminum alloy, which is known as aluminium lithium alloy. It is being used in aircraft and aerospace industry. So low density, high specific moduli, excellent fatigue, and also low temperature toughness, and can be precipitated hardened. Costly, however, is quite costly compared to conventional Li manufacture. Magnesium and its alloy. Okay, density is around 1.7 gram per meter cube. So it considered lowest among all structural metal. So it's used when lightweight is important. Okay, HCP it consists of HCP structure, which making it relatively soft, low elastic, and modulus. It's difficult to deform at room temperature, so most fabrication is by casting or by hot work at temperature between 200 to 350 degrees Celsius. So low melting temperatures is around 651 degrees Celsius. So relatively is quite unstable and susceptible to corrosion in marine environment. However, it has a good corrosion resistance at normal environment. Fine magnesium powder ignite easily when heated in air. So you must be careful when you're exposing this type of fine magnesium powder. Classify as cast or rod. Classify as rod or cast metals. Okay, some are heat treatable. Okay, as aluminum, zinc, and magnesium are rare earth metal, a major alloying element. So magnesium alloy have replaced engineering plastic since it have comparable density, stiffer, more recyclable, and low cost to produce. Okay, so thank you all. So we end this class at slide number 23. So this will be the first part of my lecture regarding this type of metal alloy and and its processing method and also application. I will further explain to you regarding the other type of metal alloy, its processing condition and also application in my second part of my lecture. Thank you for so much for listening to my class. Hope you have pleasant day ahead and thank you so much. Bye bye.